As promised, we're going to do a bunch of drills now. There's going to be 3 drills. Take your time. You can do this at whatever pace you want. But really, I want to continue to encourage you to really do these drills. This is really where you figure out, have you understood all these concepts or not? So it's important to get through them. And if you don't get through them, it's okay, but make sure you come and look at the solutions. And if something is not clear, you should come talk to us during our office hours. So here's the first one. Please modify rather, and the appropriate ball member function, so one of the functions inside of that class, so that when the ball strikes the floor, the bottom of the canvas, it bounces upwards. Okay? So let me go ahead and just show you an animation of what that should look like, so you get an intuition. And then when we come back, I'll show you my solution. So your job is, again, isolate one of the functions that is responsible for making sure that when the ball hits the floor, it bounces, and this is what it should look like. All right, I hope you got that solution to that. It's actually you have to think a little bit about where to do this, but it's a fairly simple modification. So let's see, when the ball is moving, who knows where the ball is? Update position knows. Yeah, because every time I update position, I move the XY position according to the velocity. And so if I fall off the canvas, I know that this new position has done that, and I want to bounce. Okay, so let's first figure out, how do I figure out if I fell off the canvas, the bottom part, and then we'll figure out how to do the reversal, although that's pretty straightforward. I think you probably have figured out by now. So here's what I'm going to do. I'm going to update the position. This is exactly the same code that we had in the original update position. And now that I've updated, I'm going to ask a very simple question. I'm going to say, is self.y, notice I only care about y. I'm only trying to bounce off the floor. If you want to bounce off the ceiling or the sides, you can also do it for the x and y positions to the left, to the right, and above and below. I'm just doing this one. Well, first of all, what is the coordinate down here? I have a 200 by 200 canvas. Origin is in the middle, and so minus 100 is the very bottom. So I'm going to ask, is the y position of the ball that I just updated less than or equal to, why less than? Because I want to know if it went underneath it, right? This is in the negative direction. Minus the canvas height, that's a variable that I defined up top because I didn't want to hardwire the 200 in there. Divided by 2, so the canvas height is 200, divided by 2, that's minus 100. And notice what I'm doing is I'm adding in the ball radius. Why did I do that? Well, I want the bottom of the ball to bounce, not the center of the ball. So all I did was say that the floor is where, if I just go up by the ball radius, then that means the very bottom of the ball will hit the floor. If you didn't get quite that, don't worry about it. It's fine. It's a minor detail. So if the y position is below that, that means I've just moved below the floor. Yeah? And now what I want to do is what? I want to reverse my velocity. I want to go in the opposite direction. I don't want to keep going. Well, what does it mean to reverse direction? All I have to do is negate the velocity. So I reach in and grab the object's y velocity. So what does it mean to be going down? My y velocity is negative. I want to reverse that, so I go in this direction back up. So that gives me the reversal. And then I'm going to go ahead and update the position, because if I don't do that, then the ball will keep going and fall out of the trap. So this is a tricky little thing that when you hit this condition already, the ball is below. So you have to reverse the direction and move it upwards according to that. Otherwise, on the next iteration, it will just keep going because you will have gone a little bit too low. Yeah, so I reverse it, and then the ball doesn't hide, and you see a nice little bounce. Okay, good. Hope you got that. And this is, a really nice example of where there's not a lot of code to write, but you have to think a fair amount. And so as with all these drills, spend probably more time thinking than actually coding. It'll save you a lot of time down the line. All right, let's do another drill. So now I want you to create an entire class on your own. This class is called bank account. Okay, it has one instance variable, which is the balance, and 4 methods that you are going to write. There's obviously a constructor, and it takes as input the balance. Yeah? So you pass it a number. That is your initial balance in your bank account. There is a deposit function which takes an amount and says, I'm putting this much into my account. It will add to my current balance. I can withdraw money. It takes a value and you withdraw that. And there is a function called overdrawn that returns true if the balance is less than 0. Otherwise, it returns false. Okay? So class with one data, balance. 4 member functions, constructor, deposit, withdraw, overdrawn. And then what you need to do always, always, always is test your code. So write a small, what we call driver code to test all of the functions. And here you have to start getting sort of creative. So what do you want to test? Well, obviously I should be able to create an account and check the balance. Maybe you want to write a print statement, a print function, the str, so you can check the balance too. You want to be able to test multiple deposits and make sure that money keeps getting added. You want to test withdrawals, make sure the money gets decremented. And you want to test overdrawn when it is overdrawn and when it isn't overdrawn. So you have to think about all the possibilities that can happen and write a little bit of driver code to make sure that all of these functions are working as you expect. Okay, full-blown class. Write the class function called bank account and then the driver code to test it. Okay? And then when we come back, I'll show you my solution. Okay, let me show you my solution. You can see here I have a class bank account. I'll show you the driver in a little bit. And you can see I added a print function in here. You didn't have to do that. You could have just printed out the balance. But I like writing the print function because it just makes it a little bit cleaner. I have a constructor, my deposit, my withdraw, and my overdrawn. And there's my print. So let's go through it. Class bank account, colon, everything is indented. So all of these functions are member functions associated with that class. I have my constructor, underscore, underscore, init, underscore, underscore, self, that will eventually hold the address of the object that will be created, and I'm going to pass in some initial number that is the balance. If you wanted to, you could have put a check in there to make sure it was greater than 0, to make sure it was a number. I didn't do that for simplicity. That is a value being passed in at the time that a bank account is being constructed, at the call to the constructor, and I'm going to define the object's instance variable called balance to that value. Okay? So there's my constructor. Single number, that's all I have to do. I now have an object called of type bank account, and it has a single data associated with it, which is a number, which is the initial balance. Now, if I want to deposit something in, obviously the deposit function always says self. That will eventually hold the address of the object that is calling this function. How much do you want to deposit? And then I'm going to take the current balance, self.balance, add that to an amount, and then create that to be the new balance. The withdraw is exactly the same. Amount comes in, I decrement, there's the minus sign, and then I update the balance. Overdrawn doesn't take any parameters, right? It just says, am I overdrawn or not? And so all I'm going to do is return whether the balance is less than 0. Notice, by the way, I've done this in one line of code. You could have done something like variable name equals self.balance less than 0, return that variable name. No reason to go to that fuss. You don't need to assign it to a variable. That's going to value to Boolean, return it. You could have said if self.balance is less than 0, then return false, else return true. Perfectly fine. But notice when you're testing self.balance less than 0, that is the answer. So you can just return that. So this is just a nice little elegance where you don't have to create a lot of code around it. If the Boolean expression is what you want to return, well, just return it. Don't wrap it into a conditional and don't wrap it into a variable. So that'll return a true or false. And then my print statement, of course, says balance. This is just my choice. I can have a print do whatever I want, plus, and then I convert the balance to a string. And don't forget, you have to return it. This print statement is not printing it. It is handing it back to Python's print function for it to do the printing. Your job is to return a string. All right, now let's look at my driver code. And there's no absolute right or wrong answer here. You just have to take it out for a test drive and make sure everything works. So this is probably what I would consider a bare bones driver. I'm going to create an account with $150 in it. And I'm going to print my account so I can see that the balance is 150. So this is why I like the print statements. How do I know the constructor works? I need to look to see what the value is. Now I could have said print my account.balance, but I like creating these print statements. It's a good habit to get into. So that will print balance 150. Let's test the deposit. Deposit 200, print the account. What should the value be? It should be 350. Let's test the withdrawal. Withdraw $50 out. And now you can see that the balance has decremented to 30. Let's test the overdrawn function. So print myaccount.overdrawn. That will return true or false. So it is false because I have $300 in the account. Now let's overdraw it and test that account. So I'm going to withdraw $500. Now I know that the balance is less. I'm going to go ahead and print the balance just to make sure that I can deal with negative numbers. I can. And then I'm going to ask if my object of type bank account is overdrawn, and it is. So you can see here I've taken every one of these things out for a test drive. I've tested all the possibilities. This is probably bare bones. You could have done a couple more, created a couple different accounts, make sure they don't collide with each other. And again, this is more of an art than really sort of hard and fast rules. And you just got to think through what are the various possibilities and make sure that your function is operating the way you expect it to. Okay, good. So let's do the last drill. I would like you to create a class called Kangaroo. And it has, of course, it has a constructor. And the constructor initializes an instance variable called a pouch contents to be an empty list. So now the data associated with the kangaroo is going to be a list. And initially it's just an empty list. Okay, that's it. Now you're going to create a function called put_in_pouch, and then you're going to create a print function. So put_in_pouch takes a string as input and adds it to the kangaroo's pouch, which of course is the list. Okay. If that string is not already in there. So if the string is already in there, then print object already in pouch and don't do anything. So if I add something into the pouch, like a bowling ball, and then I try to add a bowling ball again, you shouldn't put 2 bowling balls in, only one at a time. Okay? But if it's not, then you should add it to the pouch, and it doesn't matter where in the list it is. The print function should print the kangaroo's pouch contains, and then print out everything that is in the list. Okay? Good. Again, as always, write a little driver. So create a pouch. Print its contents, add something, print its contents, add something in, make sure it got added, print its contents. Try to add something twice, make sure you get the message saying this is already in here. All right, take some time. Again, full-blown class, constructor, put_in_pouch, and a print function, and the data associated with this particular object is going to be a list that we will be adding to using the put_in_pouch. And when you come back, I'm going to show you my solution. Okay, here's my solution. Again, I'm going to separate out the class from the driver, so let's do the class first. All right, I have class kangaroo, I have my constructor, my put_in_pouch, and my print function. So the constructor is trivial. In fact, it doesn't take any input. It's just self. Why? Well, I said the initialization is an empty string. So self.pouchContents equals open bracket, close bracket, done. Nothing to do. Constructor takes no input. Fine, perfectly fine. Put_in_pouch, it takes a single parameter's input x, and what you have to do now is add it to the pouch if it's not already in the pouch. So now you got to do a little bit of work. So I've got to go through the pouch and check to see if that element is in there. All right, let's go ahead and do that. For I in range, the length of self.pouch_contents. So self is the object, and I'm going to grab the pouch contents, which is the list. And I will take on every index from 0 to the length of the list minus 1. And I'm simply going to ask that if self.pouchContents sub I is equal to x, that's what I'm trying to insert into the list, then print already in pouch. And what do I do now? I'm done. Go home. Return. Return out of the function. There is nothing to do here, right? There's nothing to add to the list. You don't have to check any more elements. You found it and you're done. So for every element in the list, check to see if the object exists. If it exists, print a message and boot out. And if I get to this point in the code, after the whole for loop is executed, what do I know? Object's not in the list, right? Obviously not. Otherwise, I would have hit this statement, I would have printed this, and I would have returned. So at this point, I can simply append the object to the list. So let's follow this. Self, what is that? Address of the object. Pouch contents, what is that? The the list associated with this object, and that is a list, so I can call the append function with the element that I want. So look at the 3 levels of indirection: object, data associated with the object, member function of that list. Okay, right there. Good. Let's look at the print statement. This is pretty easy. If the length of self.pouch contents, that is the list, is 0, then just say the kangaroo's pouch is empty. There's nothing in there. Otherwise, say that the kangaroo's pouch contains, and then I'm going to take the list and just convert it into a string, which you can do, of course, or you could have put that into a for loop and printed them out, and then that will print the contents of the list of the pouch, which of course is just a list here. All right, let's go ahead and look at the driver now. So I'm going to create a kangaroo object, call that capital K, and I'm going to go ahead and print it. Let's just make sure that the first thing works, and it'll say the kangaroo's pouch is empty. Good. That tells me that the constructor worked and I have an empty list. Let's add something to the pouch. K.putInPouch, a ball, there's a string, and then print K. The kangaroo's pouch contains, and then it shows me a single object. Let's put something else in there, make sure I can get multiple things in there. Good. So that now tells me that when I put the hammer in, I print K, I get a ball and the hammer. And one more test, let's make sure that it can deal with multiple objects trying to be put in. So if I try to put a ball in, it will say already in pouch. And I'm going to just print that and make sure I didn't screw anything up. So you have to be careful here. Maybe I got the message right, but I still added it. So when I print it, it should only say ball hammer. And really probably what I should do here, because this is testing if the first object in the pouch is an object, I probably should have also tested hammer to make sure I'm iterating through that whole list. So you probably want to drive this a little bit more with a few more test cases to make sure you can find an object regardless of where it is in the list. But again, just basic functionality testing, make sure your functions do what you think they do, because one of the hard things with, well, really any code, but particularly these member functions, is you got to drive them. You got to run them, and you got to test all of them, even if you don't know that when or how they're going to be used. So that testing code we'll see more and more of in the coming weeks to make sure we know how to verify that our code is doing what we think. All right, that's it for now, and when we come back, we're going to have a little bit more talk about objects and classes and start refining some of our thinking about these things. So we'll see you in a little bit.